In this video we're going to look at the Pythagorean theorem, and we're going to use the theorem to solve the missing length on a right angle triangle. So the Pythagorean theorem states that c squared equals a squared plus b squared. We can use any variable we like. We can call the variable anything we like, but normally we call the hypotenuse c and the other two sides of the right angle triangle a or b. So I've drawn a right angle triangle here, and I've drawn a square of each of the sides of that right angle triangle. We have the hypotenuse, which is always the opposite of the 90 degrees there in the corner, and I've drawn that square here. So c squared is the area of that square. Now a and b can be either side of the right angle triangle where the 90 degree is. In this case I've drawn a here, so this area is a squared and this area is b squared. So Pythagorean theorem states that the area here, c squared, is equal to the area of a squared plus b squared. So if we were to add these two areas up, we'll get the same area here. So we can use this fact to solve the missing length on any right angle triangle if we're given two of the other lengths. It doesn't have to be these two, it can be this one and the hypotenuse. As long as we're given two of the sides, we can solve for the third side. So let's solve for the missing side here, which in this case is the hypotenuse because it's opposite that 90 degrees. So we'll call that C, we'll call this A, and we'll call this B. So let's write down our formula. C squared equals A squared plus B squared. And let's plug the numbers in. So C squared equals 12 squared plus 22 squared. Now we need to know C, the length of that hypotenuse, but C squared is the area. So to get rid of that square we need to do the opposite, which is the square root. So we would take the square root of the left hand side is equal to the square root of the right hand side. So the square root will cancel out with the square, and that will leave us with C equals 12 squared plus 22 squared. We can do that on our calculator, and the answer is 25. The units is meters, so C is equal to 25 meters approximately. That's an approximate. There is a few decimal places to that. We can use the Pythagoras theorem to solve for other missing lengths on a right angle triangle. In this particular case, we're given the hypotenuse length, but we're not given the other side length. So we'll call that C, and we'll call this B this time, and this A. It doesn't matter which one, A or B can be either side. We always write down our formula. C squared equals A squared plus B squared. We can plug the numbers straight in, or we can rearrange the formula to solve for B, then plug the numbers in afterwards. In this case I'm going to rearrange the formula first. So we need to find B here. So let's take C squared, take away the A squared on the right hand side, take away the A squared on the left hand side, equals B squared. We need to get rid of that square, so we'll take the square root on the left hand side and the right hand side. So C squared, take A squared, take the square root of that, equals the square root of B squared. So B equals the square root of C squared take A squared. Now we can plug the numbers into our rearranged formula. So we have the square root, C is 10 squared, take away A squared. If we were to plug this into our calculator, we'll get that B equals 6, and we're in meters. So this is how we can use the Pythagorean theorem to solve for the missing length on a right angle triangle. It will only work with right angle triangles. We can't use this on any other type of triangle.